or an advanced novice, there's very little here that's new. But if you would like to hear more about Git, if you have like developers in the office going, oh, just Git it or whatever. I don't know what I don't know. We spend more time on the command line than like talking about what we're going to do on the command line. But yeah, then this will be interesting. So this is this assumes very little background. I assume that you do use version control. If you don't use version control, then the choice of which version control system you use is probably best left to a later time after you decide to actually start using version control, because you should do that immediately. So let me say a bit about myself. I work at Agileware. We use Git every day. I definitely spend a significant amount of my time on the command line doing things in Git. And Git is a version control system. It's a distributed version control system, which means that in theory you should be able to do your development in a distributed manner and just merge things into each other's repositories as necessary. But in practice, we use centralized version control a fair bit. We use Bitbucket. GitHub is a good choice for this demonstration, which is why I'm using it here. And so I'll just get started. So this is a basic introduction to Git. It has very contrived toy examples. Some of these examples are very, very relevant to things that you do in production when you're actually doing your work. So I'm just going to full screen that again. So if you've come from an SVN background, which is kind of the background that I assume that you have because SVN's been in use for a while, then the words checkout and commit mean very, very different things. I think SVN CO and SVN commit are different. So the major difference between Git and SVN is that Git has, instead of just having your repository and a remote repository somewhere that you push or pull to, you have your local repository, you have a staging area, and you have your remote repository. So you have your working directory where your files are, and then you make your changes to your staging area. You stage your changes to like this area in the middle before you actually push it up to the remote repository. And when you pull down your changes, you can fetch your changes, which I'll get into that a bit later, but they put them into kind of, I guess, the remote equivalent of a staging area, which that actually allows you to, before you can actually pull them into your working directory. And the thing is, in SVN, I think we used to thinking of changes as as deltas between different versions of a code base. So there's a code base, this is a change, this is another change. But in Git, it's slightly different. Each commit represents a snapshot, the entire repository. And that's like, so it's one change, it's one commit, that's another commit, so on and so forth. And I use ASCII art because the system that I decided to use for my presentation makes it really hard to include images. So sorry about that. There will be fewer images after. And another thing you need to know about Git is that every commit, every change has a unique SHA-1 identifier, commit hash, which is this way of uniquely recognizing it in a repository. So I will get started. So this presentation is called Get It Going because an old housemate of mine worked as a bar manager in a restaurant, and at every opportunity he'd say, let's get it going, let's get it going. So hence my love of bad Git-related puns that you will probably see in this talk. So if I were to, where's my mouse? So if I were to remove my Scratch directory, make a new one. Then I do, so this is one of the first commands that you need to know. So git status is so the other thing about Git is that I found, especially when I was learning it, that the documentation ranges from, completely absurd to occasionally helpful. And it's a bit of a struggle when you're trying to learn it for the first time because, you get this thing like git status, show the working tree status. What does that mean? So git status will show you the status of your working, of the files in your working directory. And it gives you this, somewhat helpful error message, and it says, oh, it's not a Git repository, and that's fair enough. I haven't created a Git repository yet. So you do that by going git init. So it says, yes, I've created a new Git repository, and then you do git status again. And okay, I'm on. Fine. So it gives me all this stuff. And it's like, okay, Git's giving me output that's not completely useless now. So the important thing, one thing to know about Git is that all the information of a Git repository is effectively stored in the .git directory. So I can show you that by going, by removing the Git directory and just trying Git status again. Same message I got before. So I've effectively removed my Git repository and turned my directory back into a regular directory just by going Git. Yeah, we're just removing the Git directory. So this is a local repository. What's on that? But there's also a remote repository, and I'm going to kind of simulate that by creating a new repo. Let's see if I can figure that out. So that's a nice name, fictional memory. And it's public. Doesn't set up instructions. Hop back to my. Can everyone see my terminal? Is it too small? Yes? No? Maybe?
No.
Yeah, anyway. I'm going to assume that you can see it. So, back to, where is it? There we go. So, as I mentioned before, there's 3 things you need to be aware of with the Git repository. There's your working directory, or your working tree is what it's called in Git lingo. There's the index, the staging area, and there's a repository, it's a remote repository, which I'm going to simulate in this talk by creating this repo on GitHub. Repo is short for repository, in case it wasn't clearly immediately obvious. So anyway, if I go to Git status again, I haven't created a Git repo, so create a Git repo, then I go, okay, so this is somewhat helpful error message. I remember like when I was previously looking at it, it's completely useless, but now it at least tells me you have no commits yet. So I'm like, okay, fine. So then you can do a git diff as well, but anyway, I'll get into that a bit later. So if I to do that, it tells me it's an untracked file. So Git doesn't know about this file. It doesn't tell you. It says it's untracked. Git doesn't, as far as Git's concerned, it doesn't exist. So if I try to like edit my file and do like a Git commit, it doesn't automatically pick up, say, oh, there's this file. Do you want me to be helpful and add it to the repository for you? It just doesn't. You actually have to add it to your repo. You have to say, Git, I want you to care about this file. And then you do a git. So git status is a really useful command. As you can see, I've done it at least 5 or 6 times already. So it says, okay, now there's this file that I now care about since you told me to care about it, called readme. And if you just do a git commit now, without putting in a commit message, it'll just, no, I refuse to commit this file. So fortunately, instead of like opening up a text editor every time, you can just go. And I think the standard message when you're starting a repository is just initial commit. That's fine. So you can do a git status. And I remember the first time I tried to use Git for a project. I was using it for a class project, and the person that I was working with, I kept doing all these commits, and I thought I was doing a great job implementing all of these all these functions. And then I was like, hey, Lewin, can you see my changes? And he's like, what changes? And I was like, well, I committed them. He's like, yeah, but did you push them? And I was like, what? And it turns out that in Git, it's not enough to just commit your changes, because like I said, committing them moves them to the staging area, but not the remote repository. So it's like, okay, fine. So you actually need to put them on the remote repository for someone else to see them. So once I've created this repository, then GitHub, to its credit, gives you excellent instructions on how to actually create a new repository. So I've done kind of all of this. I've like edited a file, done my init, my add, my commit. So I can skip to this set of instructions, which tells me that this is called a remote. So it's a reference to a remote repository. So I've created my repository, but I haven't told it about the remote repository that exists. I told it that that is the remote that corresponds to this repository. So I just add that line in. Yep, and Git's like, sweet, no worries. Then I'll move back to the screen so I can see my instructions. And then Git. So this is a failure of my instructions. So if there's one thing I should probably mention. So git diff at this stage, there's a difference between my repository and the empty remote repository. But git diff only shows you the changes between your working directory and your index by default, which means it won't show me anything because there's no changes between my working directory and my index. I've added the one file that I had. So the other thing you can do is do a git diff of your staged changes, which isn't giving me anything either because I've already committed it. Anyway, I'll get into that a bit later. So then you can push. See, and this is another thing, like update remote refs along with associate. What does that mean? Would be the way that I would describe this is that it updates a remote repository with commits that you specify. So anyway, I've created my thing. Hopefully I should be able to see my changes now if everything has gone to plan. Yes. So successfully created a new file, added it to the staging area, pushed it up to remote repository. It's showing up in the remote repository. That's awesome. So this is the most important part of the talk. I feel like I need to stop and say this. If you take nothing else away from this talk, remember that when you're using Git, you need to add your file, commit the changes that you made, and then push. And then when you, anyway. Yeah, that comes a bit later, actually. I'm not sure if we have time for that, though. I hope so. Anyway, so if I edit my file in GitHub, and I'm a bit conflicted about GitHub, actually, because it's very cool, and lots of people use it. But I find that, at least when I was learning Git, it just made it too easy for me to do things without actually understanding all of the commands that I would need in order to actually replicate that process on my own system, on the command line. So, yeah. So then I do, so again, download up. So I only recently started getting into the internals of Git. And so only now, after a very long time using Git, I've used Git for about, let's say, 3 years now. Do I actually understand what an object in a ref is? But I don't expect anyone else to understand that. And I feel like it's, again, an example of not very helpful documentation. These instructions are taken straight from gitscm.com, like this documentation. And I feel like it's a barrier, which is one of the reasons I did this talk in the first place. So anyway, you do a git fetch, which means that it updates, makes Git aware that the remote repository that has been specified has changed. Okay, so it gives me all this output, but it also tells me, most importantly, that something's changed. If it doesn't give you output, if this command doesn't give you output, then you can, well, in most cases means that nothing's changed, but it has given me output, therefore something has changed. So I do a git status. Nothing's changed on my local repository. And then I do git log, still the same. You can actually, So anyway, so then if I do my git merge. So this was, so Git has, by convention, specifies that the origin is the name of the remote repository that's associated with your local repository, and master is the name of the branch. And I'll get into that a bit later. But so it says that it fast forwarded. Fast forwarding means that everything's sweet. It basically, your file and the remote repository's file were the same in that, same before the change. So it was just able to apply the changes that it made on top of your current changes. So it just, it's like, So Git, git fetch and a git merge is equivalent to a git pull. I can demonstrate. So a git pull basically, instead of when fetching didn't update the state of my local repository until I explicitly said that I want to merge the changes from the remote repository. But the way that you can do that automatically is by doing a git fetch and a git merge simultaneously in one command. And that command will get is named git pull. So I will demonstrate that just in a second by doing this again. And update and fix the typo. Sorry about that, guys. So if I do that and then I hop back into my, then I do a git pull. You can specify, like I don't have to specify origin master each time, but I'm doing it in this case for consistency, so you know exactly so you can see exactly what's happening. So yeah, it did a fetch. You can see the output is the same as a fetch would have been, and it did another fast forward merge because it just did a fetch and a merge, one after the other. Yeah, so you can check that my working directory is fine, and you can do a git log. I don't like this format of git log that it gives you by default, so I like to do a one line. So you can pass it a one line option, which will, makes things a bit easier. So, back. Comes a bit later. Yes. So git revert is actually well described. It creates a commit that applies the reverse of a previous commit, so it unapplies changes, or it applies the opposite of changes. And head is a reference to the most recent commit, the tip of the most recent commit. So if I go git revert head, it'll create a commit that is the opposite of. So hopefully creates a commit that says, okay, revert that previous change. That's fine. I want that. Git reset. So git reset will update the state of the repository without changing the state of your working directory unless you tell it to, it'll update the state of your local repository without updating your working directory unless you tell it to do so. We'll get into that, I think. So if I do a git, so like I said, so it changed. So it changed the state of my repository without changing the state of my file, and I can verify this by going. So the change that I made on my remote repository, pulled back down, is now gone in my repository, but it's present in my file. Anyway. So if I wanted to match the state of my repository with the state of my working directory, you can use reset as well. And this is something you should be very careful. I would very highly recommend that you think several times very carefully about doing this, and because this is one of the few things in Git that actually loses data. Like once this is gone, like it's not coming back. I can't, based on the information in my repo, I can't reconstruct this information, at least not easily. So if I do a git status,
you can start cloning it first before you do anything.
Sorry?
You can start cloning it first.
Yeah, I mean you can make a backup, I guess. There are ways. It is possible, but it's unlikely, and it's the kind of thing that you only do once you're definitely sure that you actually want to just move the repository and all the files in that repository exactly to and your working directory to a certain state. So I did a git reset. You can do git checkout as well. Anyway, I should note to myself to tell you guys to be super careful with git reset hard. I've done that. I feel like I've fulfilled my duty. You can also do a git checkout, which will take my working directory and match and a file path or whatever. So this is head kind of ~2, which means 2 commits before head. And I want to change readme to that state. So if I do a git status, just change readme. So if I do git if, that's a bit strange. Oh yeah, like I said. Yeah. So it's, but so Git reset and Git checkout are kind of in this sense the two opposites of each other. So Git checkout changed my file without changing my repository. I guess I should show you that. Yeah, so my repository is the same, but my file has changed, whereas git reset changed my repository without changing my file, my local repository. Yeah, so do we git reset again? So now I've removed those changes that I just made, so I'm back to one commit before. One commit before I am on. Actually, no, I'm the same. Yeah. So this local repository and my remote repository are both in the same state because I reverted a commit and then I did a whole bunch of resetting and checking out and things like that. So far, yeah. So that's pretty straightforward. So you can reverse the changes that you made in a commit. You can bring a file or files back to a state that there were a few commits ago. You can change you can do all of that. That's pretty straightforward. Yes. So anyway, so now I'm going to update this file on my local repository. And then I'm going to update it on my remote repository. I'm going to commit this change that I made as well. Okay, so I've updated the file in a different way on my remote repository, and I've updated the file in a different way on my local repository. So one thing that one of my mantras is that you should not go git pull. I'm doing it here for demonstration purposes only. So it should give me an error message. Yeah, there's a merge conflict, which basically means that it tried to sync the changes, synchronize the changes between my remote repository and my local repository, and it couldn't because I made different changes. So it says that it gives you conflict markers. So this is the way the file is on the local repository, and this is the way it was updated on the remote repository. And I always have trouble figuring out are these the changes that I made here? Are those the changes that I made there? But it is consistent. So it's just I guess a matter of figuring it out. So I actually just wanted to remove the conflict mark. I'm quite happy with the change that I made on the remote repository. I just want both my changes in there. So you can do that. And so what the instructions that you gave me in this case were fix the conflicts and then commit the result. So I'm doing that. Then I can do git push. It should work. Okay, so I've successfully updated my remote repository with the changes that I just made, and I fixed my merge. And so far, if you're just one developer, you don't really have to worry about merge conflicts so much because it's just you. And but so far, Git's just a more complicated SVN. You're not really getting anything from all the complexity that you get with this staging area and pulling and pushing and fetching. It's not so much fun. So what's the point of Git? Why Git instead of another version control system, instead of SVN? So one cool thing that I should just show you before I go further is that it does give you a GUI. So you can see that I branched off and I like committed my changes after. That's nice. That's cool, I guess. If you want to like, if you're a bit more visual and you want to see how everything looks, it's useful for that. But what Git really gives you is branching. Yep. Oh yeah. Anyway, so yeah, this is the part of my slides I should have gone to a bit earlier. And branching, I guess. So I mentioned Git. So Git checkout does more than one thing. It was a few slides ago, but so you've probably forgotten. But it doesn't really matter because it doesn't illustrate. At least the help text doesn't illustrate the usefulness of Git checkout in this instance, which is creating a branch. So one of Git's main selling points is that it makes branching easy and cheap. So you can create different development histories and then merge them back into each other if you want. With SVN, as far as I'm aware, it actually creates a different copy of each file and puts that in a different directory, and that's how you branch. Git does it a lot better, which is, I guess, one of the best things about it as a version control system, aside from the fact that it's distributed. So what I'm doing now is that I'm creating a new branch called branch A off of master. So I've done that. I'm going to put in all these options. So now it actually shows you something that looked kind of like what GitK looked like, but in my console, which is pretty nice. So it shows you that I made my initial commit, did some updates, and then I like kind of diverged, and then I merged my changes back in. So yeah, so that's pretty nice. And there's a shortcut that will add all the files that Git knows about and called -a. So now I've added and put in a commit message with one command. Yeah. So if I do my git log again, so I've done a batch specific commit, but origin, master, and master are still on my previous commit, so I can. Yep, I'll do that again. So yeah, as far as my master branch is concerned, I just haven't made any changes. And master is just a convention in Git. Master is a convention for the first branch you create and the branch that, well, is the master branch, but it's just a convention. You can call it whatever you want. Anyway, it's going to get into a bit more like nasty branching, but that's primarily the advantage of Git-ing. And yeah, do we have any questions? I feel like we have time for maybe one or two questions. Yes, Tim.
The shortcut for adding and committing files at the same time. You said that putting -a adds all the files that Git knows about. Is that only files on which it detects a change, or is that the entire local repository?
So it's files that aren't untracked, I think. But again, like it's a shortcut. I wouldn't recommend using it. As you can see, I've been I think I've been pretty good about just adding and committing changes at the same time. Sorry, I haven't done that. I've done an add and a commit as separate operations, which is the way it should be, I think. Yeah, any other questions? It's basically like Git gives you all these shortcuts, but for good reason, you shouldn't use most of them. Like pool, for example. Pool is a convenient shortcut, but there's lots of, in any instance where there could be a conflict, you want to be very careful. And you just want to do a fetch and a merge separately because those are easier to kind of undo than just a pull. Any other questions?
Sort of will be easier to use some GUI interface where like maybe source tree or something.
I thought about this. There's a couple of disadvantages for the work that we do, sorry, it's more sources, more questions, more bad image positioning on me. I remember when I first started out, I was like, I just wish there was a GUI that would help me do all of these things. But the more comfortable that I got, the more you actually understand what's actually going on. You have a mental model in your head of what's happening to your Git repo every time you make these changes. I'm more comfortable with the command line. And a lot of the work that we do at Agile was actually on remote development servers. And I don't think I found a tool that will actually connect to a remote server and give me the GUI that I want. And the command line access that so if I know how to do something in the command line now after using Git for so long, then it's not easy to kind of, go back and try to do it via GUI.
But I mean, it's sort of much more visual way. I mean,
Yeah, so for some things it's quite nice. Yeah.
One line things like that.
The GitHub GUI is quite good. I quite like using the GitHub GUI on Windows, and but in general, I think once you make enough Git mistakes, you probably just get the hang of it,
Yeah.
like I did. So yeah, thanks.